The simplest organic compounds having hydrogen and carbon only are called hydrocarbons. The main chain of hydrocarbons is made by the carbon-carbon bonds, and hydrogen atoms are attached to carbon atoms. For example, petroleum, natural gas, coal, etc. Therefore, hydrocarbons are regarded as the parent organic compound, and all other compounds have been said to be derived from them by substituting one or more hydrogen atoms by functional groups. Based on structure, they can be broadly divided into two types, that is, acyclic and cyclic hydrocarbons. Acyclic or open chain hydrocarbons or aliphatic hydrocarbons are called so because they contain an open chain of carbon atoms. They are further classified into two types based on presence of single or multiple carbon-carbon bonds called saturated and unsaturated respectively. Alkanes come under the category of saturated hydrocarbons, while alkenes and alkynes fall under the category of unsaturated hydrocarbons. This classification is primarily based on the type of carbon bond present in their molecules. In this video, we will deal with the basics of hydrocarbons as in their types and structures of acyclic hydrocarbons only. Before moving forward, let us first recall what does the root word in these hydrocarbons mean. If the number of carbon atom is 1 in a hydrocarbon, then it has a root word meth. For 2 carbon atoms, it is ith, and for 3 carbon atoms, prop is used. Subsequently, they are bute, pent, hex, hept, oct, non and dec for others till 10 carbon atoms. Primary suffix for saturated carbon chain with carbon-carbon single bond is ane, hence called alkanes. For unsaturated carbon chain with carbon-carbon double bond is ene, hence called alkenes. For another unsaturated carbon chain with carbon-carbon triple bond is ine. Let's consider them one by one now. Alkane has only carbon-carbon single bond. For example, CH4 methane, CH3 ethane, CH3 CH2 propane, etc. These acyclic saturated hydrocarbons are called paraffins. Why? In Latin, arum is equal to little, affines is equal to affinity, because they are relatively unreactive towards most of the reagents such as acids, bases, oxidizing and reducing agents. However, at high temperature and pressure, they do undergo reactions like nitration, halogenation, pyrolysis, etc. The process of naming the alkanes is quite interesting, having a general formula CnH2n plus 2, where n is equal to 1, 2, 3, etc. We will take IUPAC naming of these hydrocarbons in another video. Next, alkene has at least one carbon-carbon double bond. For example, ethene, propene, butene, and pentene. These acyclic unsaturated hydrocarbons are also called olefins. In Greek, olefin is equal to oil forming. Since their early members like ethene, propene produce oily products on reaction with halogens such as chlorine and bromine, the general formula is CnH2n, where n is equal to 2, 3, 4, etc. Moving ahead, alkynes are acyclic unsaturated hydrocarbons containing at least one carbon-carbon triple bond, for example, ethine, propyne, butane and pentine, etc. The general formula is CnH2n minus 2, where n is equal to 2, 3, 4, etc. Hence, common alkanes are methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane and decane. As alkenes begin with ethene, followed by propene, butene, pentene, hexene, heptene, octene, nonene and decene. Lastly, alkynes are ethine, propyne, butane, pentine, hexine, heptine, octine, nonine and decine respectively. With this, it's a wrap. Hope you found this video informative. For more such insights, keep watching and keep learning. Thank you for your time.